And thanks a million for this.
No problem. Okay, so my name's Duncan Mc Laren. I'm a research fellow at the Lancaster Environment Centre, and today I'm going to be talking about the research we've done in a project looking at what we call mitigation deterrence and how it affects greenhouse gas removal or carbon dioxide removal technologies. You're going to end up with a little gap here because I actually don't have the right slides open. It was silly of me. This works now. Right, so let me try sharing my screen again. There's the right window, and hopefully that's now clear. Can you see the slides? Great. Okay, so thanks for the invite to talk. Thanks for the making time to listen. Most of what I'm going to talk about today is findings from a project called AMDEG, Assessing Mitigation Deterrence in Greenhouse Gas Removal. It was done at Lancaster with a number of colleagues, so I want to thank Niels Markussen, Becky Willis, Bron Szynski, David Tyfield and Andy Jarvis, and of course our funders who are listed here at the bottom of the slide. In outline, I'm going to tell the story of work on what we've, as I say, come to call mitigation deterrence, a process whereby activity to cut emissions is deterred or delayed as a result of considering, thinking about, discussing, promising other ways of tackling the climate problem. I'm going to first give you some background because this comes out of a problem that was often called moral hazard and considered in the context of broader ideas of geoengineering. I'll then show how the problem is actually quite multifaceted or perhaps even many-headed. That's why the little picture of a hydra, and that it's not easily dismissed. Moreover, I'm going to show that elements of mitigation deterrence are common to a series of technological promises, each of which has issued a siren call enabling prevarication and delay. And going on to suggest that perhaps even worse, that each of these new technologies, new technological promises has been implicated in reframing, so redefining the climate targets that we set with new metrics or new levels. And in that, it's like some sort of chimera. I'll then end with some reflections and recommendations. So the concern that undertaking research into geoengineering, especially in what are called solar geoengineering forms, the idea of screening out sunlight somehow to cool the planet, the idea that that might distract from the urgent need to cut emissions has been part of the field, part of the discourse for at least 2 decades. And there's been some research into it, which may apply in this circumstance. So some experimental studies have been done. In the US, Dan Kahan and his colleagues showed that including geoengineering as a possible substitute for emissions cuts increased support for climate action by people who might otherwise be considered climate deniers, particularly those of the Republican persuasion. By contrast, in Germany, Christine Merck and her colleagues found that members of the public didn't reduce their enthusiasm for emissions cuts when they learnt about solar geoengineering. though she measured that by using their enthusiasm for buying offsets at the end of their interviews. Some advocates of solar geoengineering have gone further, using this work to claim that knowledge that geoengineering is being seriously considered might actually galvanize people into taking more action, because they see geoengineering as such a mad idea, such a bad thing, and so risky that they would rather do more short-term cuts. In the UK, researchers taken a slightly different angle and has exposed persistent fears of a political moral hazard, that geoengineering prospects enable continued political delay, avoiding costly or politically difficult decisions about things that would be controversial or hard for politicians to deliver. And as we'll see, political, cultural, and economic mechanisms are deeply implicated in the ways that carbon dioxide removal, which could also be called carbon geoengineering, has contributed to delays in action over the past decades. This, I think, becomes clearer as we understand not moral hazard, but mitigation deterrence. So the formal definition we've used here is the prospect of reduced or delayed emissions reduction resulting from the introduction or consideration of another climate intervention. So mitigation deterrent is very much an emergent, distributed, collective effect arising in conditions of deep uncertainty, whereas moral hazard, with the term taken, in fact, from insurance studies, was seen as a rational, calculative response where actors could choose to displace risk onto others by taking on insurance against the impact on themselves. In our work, we've analysed the ways in which mitigation deterrence might arise and explored them in a series of deliberative workshops with stakeholders. So giving stakeholders a chance to discuss how this might happen in different scenarios. This slide, we highlight three key mechanisms of how mitigation deterrence could arise. The first is if, quite reasonably, carbon removal or greenhouse gas removal is planned either wholly or in part as a substitute for emissions reduction, because people believe it will be cheaper or more efficient or simply easier to do. And that could be planned within feasible constraints of how much could be delivered. But if then when we get to the future where this is supposed to be delivered, it proves impossible, or it's too expensive, it's too difficult, or the carbon gets diverted into other uses, so turned into synthetic fuels rather than stored away permanently underground, that failure in the future can no longer be substituted for by increasing mitigation, increasing emissions cuts in the future. There's a huge temporal problem there. And as we'll see in a moment, that apparently rational substitution of carbon removal for mitigation happens much more often, and is much more likely than it might sound. Secondly, it's the idea of rebounds if deployment of carbon removal technologies leads indirectly to additional emissions. And indeed, we've already seen this. The most common deployment of carbon capture has led to companies buying that carbon dioxide and pushing it down existing oil wells as a way to increase the flow of oil. It's called enhanced oil recovery, or EOR. And we've seen similar problems or similar rebounds with biofuels, where land has been taken to grow biofuels, ostensibly as a climate neutral fuel, but people using that land have then moved on to clear other areas of forest or drain other peat swamps, causing higher carbon emissions. And the third mechanism here is closer to the conventional understanding of moral hazard. It's a overly optimistic imagination of so much of future GGR or future carbon removal, which allows people to slow down their efforts today, and often using offsetting promises to get there. The little bubbles represent or show representative quotes from our stakeholder groups on this slide. So these are the sort of things that people told us would be coming up. And similarly on the next slide, where we look at the drivers of deterrence, why we think these mechanisms are likely. And at the biggest level, it's almost a simple platitude. It's the context that we live in a neoliberal capitalist economy in which climate policy is framed and stated in certain ways. It almost becomes, as it's famously said, easier to imagine the end of the world than the end of capitalism. And in that situation, we tend to, and I'm deliberately saying we here, as in the collective of people who are involved in making climate policy and influencing climate policy, we tend to see it as market-based. We look at things like trading schemes, offsetting, maybe taxation, sometimes incentives, more rarely regulation. And if we're talking about regulation, it's often in terms of things like product standards. These are all within the market paradigm rather than overturning it. And in that paradigm, it's very simple for a fear of economic costs from climate action to fuel an attraction to delay, and indeed an attraction to free ride on other people's efforts. So if we're in that circumstance, then promises of future, cheaper, less disruptive solutions are going to be politically and culturally powerful. And that's not only in rich countries, but also in lower income countries that are struggling to lift populations out of poverty. There's always this tension over the costs of these activities, especially when we don't pay enough attention to the co-benefits of cutting emissions quickly. And because of short-termism in both finance and politics, these promises don't need to be delivered. They merely need to be temporarily credible. So we see highly exaggerated promises designed to encourage investors to invest in new technologies that are actually seen as credible for a few years. It doesn't matter that they're exaggerated in that sense. And carbon removal offers a very sort of novel promise compared to previous technological promises. It acts almost as a time machine because it says, with this technology, we can reverse today's emissions tomorrow or next year or next decade or 50 years hence. And that is a very different and much more pernicious promise in the debate. And unsurprisingly, such conditions can be exploited easily by vested interests. In the last year or two, we've seen President Trump endorse the Trillion Trees initiative, despite huge exaggerations of what could be captured by trees, at the same time as promoting the continuation of the coal industry. We've seen Saudi Arabia supporting carbon dioxide removal and carbon capture and storage in international negotiations. We've seen airlines and oil companies promoting offsetting. These are all using promises of removal to protect things that would otherwise be stranded economic assets: aircraft, airports, oil fields, coal mines, power stations, etc. So we think there's a very significant problem here, a real cultural drive towards this problem. We also looked at how big the problem was and made some efforts to estimate the scale of mitigation deterrence. Well, we had a go at calculating the scale of the problem. What we did here was analyze the modeled climate pathways that are widely used by the IPCC. And here we found essentially that when modelers introduce carbon removal technologies into their models, so moving from the first column there to the second column, the majority, about 70% of the deployed capacity of carbon removal, here it's labeled GGR, greenhouse gas removal, substitutes for emissions reduction because the models cost optimize and they discount the future costs of CDR. So for the models, it is entirely logical and rational to say, oh, we'll do GGR in 2070 rather than investing in public transport in 2020. So it's also, of course, the model essentializes this technology. It says this can be delivered at this level. It has to eliminate a lot of the uncertainties around it. Otherwise, it can't be put into this modeling framework. And again, cheap future action looks better than economically expensive near-term action, especially when the co-benefits of that near-term action, such as better health because of lower particulate air pollution, aren't included in the model, or better health from more walking and cycling aren't included in the model. So the three columns show carbon budgets before and after adding in CDR. The third column explains how these three mitigation deterrence effects might impact. I can go into this in more detail in the Q&A, but essentially what we've done here is first looked at that split between substitution and additional action, but we've noted that that's uncertain and therefore at risk. We've added in figures calculated based on quite conservative figures for enhanced oil recovery or indirect land use change, this type 2 at the top. And we've added an assumption that when there are promises of CDR circulating that it will cost no more than $100 a tonne, then people who are faced with mitigation, with emissions cuts that would cost them more than $100 a tonne, they are likely to defer those regardless of whether they have a contract to buy carbon removal at some point. So again, an over-optimistic expectation of carbon removal. The overall effect of this, to put it in numerical terms, is that somewhere between 370 and 550 gigatons of carbon not CO2, are at risk. That contrasts with the remaining budget of carbon for 1.5 degrees C of around 80 to 180 gigatons of carbon. So we've got an effect that outweighs the remaining budget, and at central estimates of the sensitivity of the climate, that additional emissions would raise temperatures by an additional 0.7 to 0.8 degrees centigrade, or at a high sensitivity estimate, that amount of carbon would raise temperatures by 1.4 degrees centigrade. So instead of meeting the 1.5 target, which these models were all calibrated to do, they'd be delivering between 2.2 and 2.9 degrees centigrade global warming. So to move on a little with the story, that's our concern with CDR, with carbon removal. But our research suggests the problem is and has been much more pervasive. Carbon dioxide removal, represented in the models by a technology called BECCS, bioenergy with carbon capture and storage, is just the latest in a string of technological promises which have each functioned to sort of square budgets and postpone action. For decades, it's been possible to simply shift the time profile of emissions reduction to say, okay, we don't need to do much now because we can wait and do more in the future, to move from a slow and steady or a front-loaded pattern of emissions reduction to a late and rapid emissions reduction. That's been done with promises of future emissions reduction technology, again, at a discounted cost. So my colleagues at Lancaster had already seen this with carbon capture and storage put onto fossil fuel power as an ever-promised, never-delivered excuse for continued coal use. But once we started looking, we found more. We found nuclear power promises in the earliest days of climate policy. We found fuel switching to gas, even energy efficiency being used as a promise of future action rather than immediate emissions reduction. But now, shifting the profile of emissions reduction in that way no longer works. There is so little budget left. But now we see these various forms of the time machine of CDR coming in to square budgets. Worryingly, each of those previous promises remains, we call it sedimented in the models. There's these huge layers of assumed delivery of emissions reduction through nuclear power, through CCS, through energy efficiency, even though so far they have at best been patchily delivered. Interestingly, other technologies like wind power and solar PV show almost the opposite pattern. They show they've constantly broken exceeded predictions of mainstream institutions and commentators. And what I think is going on here is essentially that dominant incumbent industrial interests will happily hype and build the hype around tech promises that could sustain their interests and sustain fossil use, but at the same time actively resist the development and deployment of technology that could disrupt their interests. So I don't think I have time to explain all the roles that I've set out there at the bottom of the table. Feel free to ask me afterwards. We can delve into that a bit further. Move on to the next stage of the story. As we explored this history, we realized that things were probably even worse than that implies. Not only had the technological promises themselves evolved in tandem with the modeling that accommodated them in line with these vested interests, but the modeling techniques themselves had developed to encompass new metrics, new linkages within the models that allowed and developed new framings of the targets, framings that increased the potential for new technology promises to support delay. So for example, when targets took the form of percentage emissions cuts, it's no good adding removals technologies into the model. They don't actually change the output that says how much emissions have been cut. For that to work, the models needed to be able to resolve for atmospheric concentrations of CO2 or for climate or for carbon budgets. And when we built those into the models, the new promises were able to square the budgets and bring slower, cheaper pathways into sight. And this, I think, gives us a lot to learn about net zero targets, the current vogue for saying we're going to have not an emissions reduction target, not even a concentrations target, but this sort of net zero, rather vaguely defined target. First, we can be clear that they accommodate much more delay in cutting emissions because they allow for future removals and they allow for higher levels of residual emissions offset by removals. In other words, they're a black box in which emissions cuts and carbon removals become fungible, tradable, exchangeable. But we also can see that they are, like targets before them, not some sort of essential representation of climate safety, but a scene of social and political contestation and debate, and likely to evolve further. So I think we need to ask, what is being balanced in this net equation? Some have already highlighted that net zero carbon is not the same as net zero greenhouse gases, because the forcing effects of other gases are different to that of carbon dioxide. I'd note that if we balance emissions, that's not the same as balancing concentrations. To get concentrations balanced, we'd need to balance emissions immediately, not by 2040 or 2050. And what worries me perhaps even more is that we will shift from understanding net zero as being about emissions or concentrations or carbon or GHGs to being about net zero forcings, net zero climate forcings. And when that happens, net zero can be a justification not just for carbon removal, but for some very positive things, some interactions on short-lived pollutants, some interventions on atmospheric aerosols, for instance. But it would also become a justification for solar geoengineering, measured in terms of its climate forcing effect. So on to the very last slide and some reflections and recommendations. So I think the first thing to say is that this sequence, this repeated sequence of delay and non-delivery of promised technologies has to be broken. We need to deliver both accelerated emissions cuts and carbon removals, and we need to look for the policy interventions that will allow us to do both. To do that, we've suggested already that separating the targets, being explicit about both emissions reduction and carbon removal targets, with deep and broad transparency and strong monitoring and verification systems, those are all critical to being able to get both of those technological promises delivered. Seems to me that we are going to need measures that are actively closing down fossil fuel production. This could be directly linked to permanent removal requirements. Miles Allen and Stuart Hazeldine have suggested a model like this, that if we do provide any license to operate in the interim period as this is closed down, we could make reductions firmer or removals firmer and transparent by having them explicitly linked. But I'm not optimistic that these sort of measures can be delivered by current climate policies and politics. So I think we do need to think about how we reject the neoliberal market-based social imaginary, which in turn resists interventions to enable communal-oriented lifestyle change and resists interventions to attack and close down fossil production at source. Those are the things we're going to need to maximise. And in addition, the practices and methods of economic modelling of climate pathways need far-reaching reform to open up new approaches, new interpretations, new pathways, and new imaginaries. So I think my final remark then is that as researchers, I think we need therefore also to be activists for social change and climate justice. Thanks for your attention. I'll flick on the slide. There is these can be made available, so all the references are there as well.
Thank you very, very, very much, Duncan. That was super interesting. I learned heaps. To remind us all of this afterwards, is it possible you can share your PDF
Yeah,
or your slides?
absolutely. Prepared it with that in mind.
Perfect. Thank you so much. So the word is open and free for anyone to ask for just by raising your hand or writing it in the chat function.
I see Alistair there. I don't know if anyone else is.
Go ahead, Alistair.
Thank you, Duncan. That was a totally brilliant talk. And